Hello and welcome to the next video of the How to Make an Operating System series. Today's going to be a different video since one of the members of my Discord asked me about where do I get my information. For that, I just wanted to show you where I get my information from. So one very important part is the arm.com website. This website is like, it has everything, an introduction in the exception model, how everything works. Like, if you have this link, you can look through most of the things that I'm doing, like the ISA, so how do the instructions work, virtualization, which I'm not gonna touch on, generic timers. This is the old architecture, ARM v7 for 32-bit processors, so that might not be relevant to what I'm doing, but these other five are certainly relevant, or rather, well, not virtualization, but all of these four. Then if we go here, memory management and the memory model is certainly important. So memory management, memory attributes, memory systems ordering and barriers. Ordering we actually already used when we used atomics, so that one would be relevant. In the memory model tool, I'm not sure about, never looked into it. And transactional memory extension, we are also not going to go into because it's ARMv9 and it's one of these advanced features. This is also not very important. The vector and matrix programming extensions, it could be that we maybe try to use them once we get into graphics or something, but I'm not sure about that. We'll see. Then gig and SMMU. SMMU we are not going to use. That's the system management unit. System memory management unit. That means that peripherals are able to use virtual addresses instead of physicals. But we are going to use the gig, the generic interrupt controller. Namely, we are going to use v3 later on. So that might be something that you might want to look into. Security. Trust zone is not for us. That's when you're building firmware. We are building an operating system, so we are one level above that. Protection for complex software, we are also not really get into it. Memory tagging, I might experiment with later, but as of now, I'm not going to enable it. MTE is not important. Confidential compute is not important. Realm management also not, and confidential compute or software stack is also not important. Then debug and trace. If you want, you can have a look into debugger usage on ARMv8A. I've not looked into the guides, so I don't know what they're about, but I assume there might be like a few useful things in there. Telemetry, we are I'm not sure if I can or will use this. I have not actually read into this yet, so that's something that I will look into when the time comes. MPEM, also not something that I'm gonna use. RAS, also not something that I want to use. These are can be interesting for like for example this one, because it shows you how to initialize a processor on bare metal. It's basically an assortment of different codes, how to initialize the memory management unit, how to initialize registers, drop into lower exception levels. So this one I certainly recommend taking a look at. And these books I have not looked into. So that's one thing. Now going back to the top here, we have two things that we want to look into besides that. That would be the ARM reference manual for A profile architecture, and in our case, the ARM Cortex A76 core technical reference manual. The difference between those two is basically the architecture reference manual defines the ARM architecture, in this case ARM v8, and it's something that every manufacturer of the processor will actually follow to be compliant with the ARM specification. On the other hand, the technical reference manual is for the core, so in our case A76, but it can be any core, A72 or whatever exists, and that is basically documentation about everything of the processor that is implementation defined. Implementation defined means it's specific to the implemented core. So if you ever see an implementation defined in the architecture reference manual, chances are that you might want to have a look into the technical reference manual of the core that you're programming for. What I would say is we are going to take a quick glance at the technical reference manual. So, or rather not the technical reference manual, but the, what's it called? The architecture reference manual. That would be, let me pull it up. That would be this one. It's quite a big, it's a huge manual. So there's like 14,000 pages, but don't be alarmed. You don't need to read everything. I did not read everything. The way you use these is more you would search for something that you want to know. Let's say I want to know how memory management works, right? Then what you can do is you go to the index and you would search for what you want. So introduction, the extensions, the programmer's model, memory model, instruction sets. Let's see. System programmer's model. Let me see if I can find the memory management stuff real quick. Memory tagging extension. But there is a heap load of stuff in there. So aarch64 we are not going to implement. That's a different, that's the 32-bit mode of the processors. But let's see if we can find real quick. So the memory model, GCS, ordering types. That's not what I want. Let's see if I can find it here on the left. So if I search for memory, what I want to see is the MMU, so the here, virtual memory system architecture. And this would, for example, be how the system architecture works. It's the virtual memory system works. It's not that easy to digest, I would say. But if you know what you're looking for and you can search for it, then you can make sense of it usually. Otherwise, if you have questions, you can always ask in my Discord, or also you can also Google. Google has a lot of different resources where people show how to make, how to use different things. So yeah, this is the architecture reference manual, and now we are going to the technical reference manual. Yeah, as I said, this is the manual that is specific to your core. And if we go to the index real quick, we see introduction to the core, a technical overview of components, instruction fetch, and other implementation details, clocks, power management, memory management unit. I think this is what I was actually looking for. Then the level 1 memory system, level 2 system, reliability, and so on and so on. For the generic interrupt controller we saw earlier, there is another manual that I'm also gonna show real quick, but I am not going to get very deep into it. So if we let's see, can I find it right now? I'm sure I have it somewhere, but I cannot find it here. There we go. Okay. This is for the generic interrupt controller, so the specification, and it's important later when we want to receive interrupts from devices. So it has introduction, distribution of interrupts, partitioning, physical interrupt handling, and so on and so on. So there's really a lot to go through, but as I said, you mostly use these manuals if you want to know how to do something, and then you look only at that specific part. So for example, I want to see the gig registers. We have a physical CPU registers and so on, and then it mentions what registers we have and where we can find out more about them. Another thing that I want to show is for QEMU. If you don't know where you can find the address of specific devices, what you can do is you can in or in a run.sh, after the -m flag, you can use a flag called dumpdtb equals. Let's call it yourDTBName.dtb. Okay, and then we specify run. And then it says, okay, it says it cannot find it, but what if we do it like this? 1 second, what was it again? Was it together? Yes, it was together, no dash. And then we see it dumped the DTB. Now we can install something called DTC. And that is the device tree compiler. So the device tree is basically a specification or a layout of how the hardware is laid out. So it's usually it is actually specific to a certain board. In this case, the QEMU vert board. And what we can do now is DTC I DTB, and then we go vert DTB. And we see it spits out a lot of stuff. So where DTS is it? And then we can have a look into the DTS. So DTB is a device tree blob, which is the compiled form, the machine readable form of the specification. And DTS is the device tree source, which is the human readable form. And if we look, for example, at, let's say, the uart, right? We had 9,000 here, and this would be our uart in this case. So PL, hold up. I cannot see. So, oh yeah, 9,000, enter. So, yeah, if we look at this, we see that it has a UART clock, and it's called a PL011. That is actually the part number that we can also look up on the ARM specifications. So if you want to know more about the UART chip that we're using, it would be the PL011. PL031 is, I think, a controller, a GPIO controller. Then here, for example, we have the interrupt controller, which would be the gig. We have flash, we have the CPUs, we have the timer, and lots and lots of other things. We know where memory starts, so this is where what I said, memory starts at the 4 million or whatever this number is. And yeah, the virtIO MMIO devices you can usually ignore. These, we didn't specify any virtIO, and I don't think virt.io MMIO is a thing on aarch64, but I am not sure. Is there anything left to say? We have PCIe, of course. Yeah, if you want to know how to read a device tree, then there is a website for the device trees. Let me see here. Device tree specification, and it would be here, devicetree.org. And if we look at this, we can read the PDF here. Or there is also, let me see if I can find it real quick. Is it this one? No. There's also an online version somewhere. Yeah. I'm not sure where I can see the online version right now, but I know there is one. There it is. It would be device tree specification.read the docs. And that's where you can read more about device trees. It's not that easy to understand. And I might actually make an episode on it, but I am not sure about this yet. We will see if we just ignore the device tree, and I'm gonna tell you, just trust me, this is where the device is for the virt board, and we're gonna use it. Is there anything else that I missed? So we went over the reference manuals. Another thing that I used was the power state coordination interface. So that would be this document. This document is for, let's see, for example, CPU on, the CPU on command that I use to bring up the CPUs. Here, CPU off, CPU on. And here you can see like what all these functions do and what your responsibilities are. And there's another document that describes where the functions are. Let's see if I can search in this document. CPU on. No, this is not the right document, but we can, yeah, you'll probably find it if you search for it on Google. It's the other document that I showed in the PSCI video. Yeah, is there anything else left to say? I think that is all for documentation right now. So I hope this was helpful, and I see you in the next programming episode.